Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at the greatest integer function. Now notice the notation first. That's the notation we use for the greatest integer function, and basically what it stands for is the largest integer that's less than or equal to the number that's inside of those symbols. We're going to sketch this graph together, starting with this table of values, starting with -2. What integer is the largest integer that's less than or equal to -2? Well, that's -2. How about -1.5? Well, the biggest integer that's below -1.5 is also -2. And -1.4, -1.3, -1.1, -1.001 are all going to go back to -2. What we're looking for is the place where the next integer jump happens, and that's at -1. -0.5 would also have a function value of -1, and then it's going to jump up when we get to 0, stay at 0 until we get to 1, stay at 1 until we get to 2, and so on. So the way this graph looks is actually like a step function. I'm going to start at this end of the table at the x equals -2 end. -2, -2 would be here, and it's going to go over to -1 where a circle is going to be, and then it's going to jump up to another horizontal line segment with the right side not included, because at 0 it jumps up to 0, at 1 it jumps up to 1, and so on. That pattern continues. So that's the graph of the basic greatest integer function. Now I want to take a look at, domain is all real numbers. How about the range? The range are just the integers, because no matter what you're getting out of there, it's going to be an integer. So the range would be the set of all integers. Let's take a look at this one. F of x equals the greatest integer function for 2x plus 1. And so what we want to think about is, okay, we know that the function steps up when we get to the next integer. And so when I see the 2x plus 1, that's telling me that things are going to happen this time in steps of 1/2. So I'm going to use a lot of different values, but I'm going to start part way down my table for x. I'm going to start at, let's start at 0. It's the greatest integer function for 2 times 0 plus 1, which is just of 1. So when x is 0, y is 1. The next jump up should happen at 1/2. 2 times 1/2 is 1, plus 1 is going to be 2. So at 1/2, we jump up to 2. When x is 1, inside that expression, we're going to have 2 times 1 plus 1, which is 3. And following this pattern, at 3/2, it's going to jump up to 4. At 2, it's going to jump up to 5, and so on. Now we can also trace our way back in the other direction. -1/2, that's going to be 2 times -1/2, which is -1 plus 1. That's going to get us to 0. -1 is going to be -2 plus 1, which is -1. -3/2 is going to give us -3 plus 1, or -2. And we can see the pattern. Now, those are the points. What I need to draw next, and this is going to be a little challenging here, but let's see if we can do that. It's going to go to the right until we hit the place where the jump occurs. We put an open circle there. Same idea here. here, here, and so on. And again, this pattern is going to continue up to the right and down to the left. So those are a couple of graphs involving the greatest integer function. I'll see you in the next video, where we're going to talk about a relation that's not a function, but it's a common graph that we do.